All right, so what I'm going to show you is how to analyze what we're looking at with these drum samples. So the first thing that I'll do is we'll take a look at some drum samples together. Oh, you know what? I need to add an audio output capture to this video. There we go. Okay. So let's just kind of get our bearings by listening to some of these samples first. So I'm going to give you access to this folder. Actually, you're going to have access to this whole samples folder, everything that we have here. So you can see that we've got rhythm, song, and speech. The one that we want to focus on first, but depending on how long it takes to get through all this, then we can do song, and then after that we'll look at rhythm. Although I have a feeling that for what we're analyzing, this group working with me, rhythm is going to be not necessarily something that we care about. I'll have to look into it and we can talk about it later. But definitely speech, and then after that, song. Okay, so let's jump into speech really quickly. This is the spoken word version.
Bí kókó bá fẹ́ ni ní ẹ̀fẹ́, a kì í jorí màdò. Bí a bá jorí màdò, àwùjọ kùmọ̀ là ní dé. Bàbá dá àwùjọ kùmọ̀, à ń mọ̀ wọn ara ẹni ni.
Okay, so that's the spoken word. And now let's go down to, this is the drum version of that same speech sample. So we can tell, I mean, if you listen to even just the very first part.
Bí kókó bá fẹ́ ni ní ẹ̀fẹ́, a kì í jorí màdò.
Just that. And then let's listen to this again. So you can tell that there's some sort of correlation there. Like we can hear that the drum is like mimicking the speech somehow. Well, what we want to know is how exactly are they mimicking each other. So the first thing that we want to look at is it the pitch contour of speech? Is that matching up to the pitch contour of the drum? Well, obviously the drum, we can only look at the pitch contour. It doesn't have all of the unique characteristics that voice does. So voice, we can look at fundamental frequency, and then we can look at formants 1, 2, 3, and possibly 4. And then we can see if that is kind of being used like in an integrated form, possibly with the fundamental frequency, to create what the drum is doing. We can also look at intensity and see which of those, if any, significantly predict how the drum plays the speech, basically. So how do we do that? Well, here's how we do it. If you've already had speech science, then you know about Prot to some extent. If you haven't had speech science, if you're haven't gone through that class, or if you're one of the psych people that are helping me, what you want to do is search for Prot, P-R-A-A-T. It's Dutch, which is why it's Prot. It's not just me pronouncing things in a stupid way. So click on this first link here, the one that has this, website that looks like it's from the mid-90s. And then over here in the top left, this is where you have some download links. So I use Windows. I'm going to click on that. If you use Mac, you can use the other. And then the 64-bit is probably what you're going to use. My guess is that most people have 64-bit systems by now. If you don't know what I'm talking about, just try getting the 64-bit one. If you do know what I'm talking about, then maybe you know what your computer has. Okay, so go ahead and download that. Once you've downloaded it, you're also going to want to download these. I should have said that. So you want to download the samples that you're pulling the data from. So you guys can decide amongst yourselves, or we can figure out how much each person is going to take on. But whatever we go with there, you can just
bí kókó bá fẹ́ ní ní
double click
ẹ̀fẹ́
on this and then click on download right there. I've already got these downloaded onto my computer, so I'm not going to do it. Okay, so now you have these files and you have prot. What do we do now? Well, what I do is I hit the Windows key and then type in, and this is on my other monitor, so it's not actually recording right now, but type in praat.exe and hit enter, and that will load prot, which looks like this. It's also going to bring up this little box as well, but this you don't need, so you can get rid of that. So we're going to use this little dialog box here that doesn't really show a whole lot. You'll click open, read from file, and you're just going to pull the file that you want. So I'm going to pull ASP1. Also going to open there we go, a DSP, which is the drum version of what we heard. So now if you click on play,
bí kókó bá fẹ́ ní ní ẹ̀fẹ́ a kì í jorí màdò bí a bá jorí màdò àwùjọ kùmọ̀ là ní dé bàbá dá àwùjọ kùmọ̀ à ń mọ̀ wọn ara ẹni ni.
it just plays, exactly what we heard when we were looking at them online. Okay, so now we're going to click on View and Edit, which is going to bring up something that looks like this. Yours might not have all these speckles on it. Mine does because I've been using this program a bit. So I'm going to get rid of all that. Okay, so yours might look like this. Just kind of a blank slate. Let me open the drum one as well. I want to show you the difference between the drum and the speech. So there are definitely some similarities. One of the things we see is there's peaks and valleys in this essentially. And what we want to know is, what about those peaks and valleys actually correlate with each other? That's what we're going to try to find out. There's definitely some differences though. So this is the speech down here. This is a spectrogram version of the speech. And this is showing how much information is actually captured in this waveform up here. There's a lot of different areas where this is showing frequency bands that are more intense than others. And if we zoom in, you can see that there's really distinct patterns going on here. These are format frequencies, and they're specific to different speech sounds, different phonemes. So you can use those to identify speech sounds. That's not exactly what we're doing. We just want to pull the different frequencies out of them. We want to pull the fundamental frequency, which is the lowest frequency that the vocal folds are producing. We want to pull the format frequencies as well, 1, 2, 3, and possibly 4 if there is enough data for 4. And those are just going to show the resonant frequencies of the vocal tract for these different speech sounds. Okay, so if you look at what's going on with the drum, we're not going to have that kind of stuff because it doesn't have the characteristics of speech. So if we zoom in, you can see there's no format frequencies for the drum. It's just hits, drum hits, right? That's it. There's a frequency. Do-do-do-do-do-do. So there's definitely a frequency there, but that's really all we can pull out of it. All we can pull out of it is a frequency and the timing of the drum hit. So it's a much lower level kind of signal than speech is. And what we want to do, again, is figure out which of the components that are in speech are being used to recreate this drum pattern. Okay, cool. So we have Prot and we have our files. So I'm going to zoom out to where we were. Well, actually, I can just click on all, and that'll show us all of the spectrogram. There we go. Or the whole file, I should say, not the spectrogram. Okay, the next thing we want to do is we want to open Excel. And that's going to think about opening for a little while. Here we go. While Excel opens, I just want to show you something else, is that the timing, okay, thanks Excel. Speaking of timing, okay, so that can go down. So the timing on this is what makes it a problem. That's what makes it a pain in the ass for us to deal with. So these do not have the same time. This down here is seconds, if I show you the blue right here. So this whole file takes 9.3 seconds to play through, and this file takes 11.7 seconds to play through. So the drum takes a little bit longer than the speech. Well, if we're going to correlate the frequency and other things with each other here, we have to have them in roughly the same times. We can't have them, all wonky like this. So this is part of the problem. What you're going to have to do is you're going to have to kind of listen to these and figure out what portions go together, and then cut out spaces, I guess is what I want to say, areas where it's really quiet. So like right here, I know this because I've listened to it already, but well, I can see that there's this. This is like a grouping right here.
Bí kókó bá fẹ́ ni ní ẹ̀fẹ́.
Okay, if I come over here to the drum, it looks like there's a group right here, but you have to listen to it before you pull it in. Another thing you can do is, even though these are different lengths, the window is the same size. So it's giving you like a proportional look at the entire file. So you can see that there's more selected here, proportion wise. More of this is selected proportionally than is left over than up here. This is much shorter. So we have too much selected here, even though we've kind of selected like something that holds together as a group. So if we listen to this again,
Bí kókó bá fẹ́ ni ní ẹ̀fẹ́.
Bika koba feni nefe, and then what do we have here? We have so it's like two things. So we can put in like Bika koba feni nefe, Ika kame jodi madu, like that. So it's also taking this portion.
Akijori mado.
Akijori madu, right? So if we listen to the whole thing all together,
Bí kókó bá fẹ́ ni ní ẹ̀fẹ́. Akijori mado.
and then we listen to this one. Okay, now they seem to match up acoustically with what we're actually listening to, and visually they match up too. The proportion that we have highlighted here is roughly equal to the proportion that we have highlighted here. This is showing the actual amount of time that we've got highlighted, which is 3.6 here and 2.7 here. So clearly the time is different, but we have the same proportion highlighted, which is what we want to focus on. Okay, so we want to grab these like groupings again and try to take a grouping that matches up down here. The groupings are usually about the same length. before there's a space. Again, here, not necessarily. There was kind of a space, and there wasn't as much of one down here. It's right here where that space is. And you can see that there's a bit of a space, but not as much as up here. So anyway, it's up to you if you want to grab. Whoa. This much and this much, or if you want to grab the whole thing. It's okay either way. Obviously, this is preferable because we're cutting out even more of the excess blank spaces here. When we put the numbers in, this is going to just be a bunch of blanks. We're going to have to cut it out anyway. But depending on, if you get through one of these and that's taking a really long time, then maybe you want to start getting like larger groups when you can. Anyway, to start out, let's do it this way. So we select our group, and let's start with the drum. What we want to do is we want to go to pitch, and we want to have it show pitch. You're not really going to see anything. If we zoomed in, you would. There's pitch right there. Now it's drawing the pitch onto the spectrogram. So it's showing us what the fundamental frequency is. If we go back, you're not going to see it down here, but pitch is there. And now what you can do is you can click on pitch, and you can tell it to list pitch, which is what we want. So what? Oh man. Okay, I guess we got to move in. That's annoying. So pitch listing. Aha, there we go. So if it gives you that error message, you just have to zoom in enough so that the spectrogram down here can be shown. And this is what we get, is this pitch listing right here. Now, you're going to highlight this. You can you can highlight it like I did and then hit Control C, or you can hit Control A. Oh, does that not work in this? Control A. Oh, well, never mind. You're gonna have to just highlight it all with your mouse. I thought you could Control A and select it all, but it doesn't like that for some reason. So you'll have to highlight it all with your mouse, bring it down, and if you can leave out all this undefined at the end. That just means there was no information there. So only go to the last actual number. So again, Control C. Now we're going to come over here to Excel, and we want to note that we did drum. And this is going to be fundamental, like that. You can also just write it as F0. That's totally fine. So what you want to do is you're going to click on a cell that you want to paste into, and you're going to go to this Home tab, and then you're going to go to Paste, Use Text Import Wizard. This is probably a crazier thing. I just recently learned this. You've probably never done it. But maybe it'll help in the future if you're doing this kind of thing. Hope so. Okay, so we have characters that are delimiting what we've got here. So we want to go with delimited. We're going to click Next. Okay. So these are actually delimited with spaces, and it's 3 spaces that make a different cell. So we want to have this selected too. Treat consecutive delimiters as 1. So now it's looking for a space that's going to cut these things into different cells, basically different columns. And if you get this little line in the right place, then you're good. Let's see, if I click on tab and unselect space, there we go. See, there's no line anymore. So it's going to import these as just everything in one cell, one big long string of text. Not what we want. So we want to make sure that space is checked here. Okay. So we're going to say next. We want to format this. General's fine. Yeah, it's fine. Then just click finish. Okay. And there we go. So this has time and F0. You can leave that. So I just made this and I didn't need it. So I'm just going to delete that. So what we've noted here is that we have drum and then we have time and F0. What I also want you to get for drum is intensity. So we're going to have another thing here for drum. And you know what? If you want to save a save a row up here and just put drum where it's time, we'll know it's time because it, moves every tenth of or like 1/1000th of a second. It incrementally moves up. So we'll definitely be able to tell which one of these columns is time and which one isn't. So you can put drum right here if you want. It's up to you, but that's probably what I'll do. Okay. So we want one other thing from drum. Let's go back to prot. Here we are with drum. In intensity, we want to click on intensity and we want to say show intensity. And now you got these little yellow... Oh, I dropped my headphones. Sorry about that horribly loud crash. Okay, so we've got these yellow bands now, these yellow contours to go along with our blue contours, and these are showing intensity. And you can see that they spike where the spectrogram is darkest, and then they kind of roll off from there. It's what we would expect. So now that we have that, we can go to intensity, and we can say intensity listing. And then just like we did with the fundamental frequency, we're going to go all the way down, select this, and hit Control-C. Back to our Excel sheet, back to paste, use text import wizard. Delimited is fine, click next, space, yep, this all looks good, next, finish. There we go. So now from the drum we have fundamental frequency, we have intensity, we're good. And I'm going to delete this other row here. All right. Now we need speech. So let's go back to prot and select our speech sample. Well, we know we want to get pitch, so we're going to tell it to show pitch. We're going to tell it to give us the pitch listing, and then we're going to copy that. Now, select the cell you want it to go into, go to paste, text import wizard, next, next, finish. Great. We want to mark that that's speech. Okay, so that's our fundamental frequency. Back to prot. We also want intensity, so we want to show intensity. We want to get the intensity listing. Paste, wizard, next, next, finish, hooray. And then here's the other thing we want to get that's new. So back to prot, and now we want to get the format. say show formats. And now we get all these red speckles. And these are showing us where our formats are. So the lowest one is showing us format 1. The next one is showing us format 2, format 3, format 4. And it looks like it's even trying to figure out what format 5 is for some of these. The formats are what create the differences in our speech sounds like E and OO. They can be produced with the same fundamental frequency, but they have a different characteristic based on these different fundamental frequencies. These different format frequencies, I should say. So now that we've got the format showing, we want to go back to format, and we want to ask for the format listing. Now, this is a much larger set of numbers than before, but that's okay. So we're going to copy all that. Control C. Back to Excel. Paste. Import wizard. Next. And now we can see they're all delimiting exactly like we want them to. We can click next again. We can click finish. And now we've got this. So we've got the drum fundamental frequency. We've got the drum intensity. We've got the speech fundamental frequency, the speech intensity, and the first 4 formats of speech. This is perfect. So then we can start correlating these soon. Not quite yet, though. There's one last thing we have to do before we can move on and start pulling in more data. Or you can do this at the end. It honestly doesn't matter to me which order you do these things. So we're going to go down to the bottom. And here you can see there is a lot of different timed data. So what I've done here is I've figured out the steps that all of these are moving in, the time steps that all these are moving in. So fundamental frequency moves in 0.01 seconds. Intensity moves in 0.01 seconds also, but it's actually not exactly 0.01. It's 0.010667. So they're close to the same time signature, but not quite. For speech, it's the same. Fundamental frequency moves at 0.01 seconds. Intensity moves at 0.01 and some change. And then format frequency is actually much faster. It's running at 0.00625 seconds. That is 4/1000ths of a second faster than either of our other 2 metrics. So when we try to equalize these, that's when it gets a little tricky. And this is, again, you can pull all of the data first and then do the second if you want to, kind of make it like an assembly line, like you do one thing, when you're done with that, then you move to the other. It might be easier. I might do that way if I were you. But it's totally up to you. If you want to keep it all orderly, you can do that way as well. All right. So how do we normalize these to each other? Well, luckily, even though fundamental frequency and intensity are measuring at slightly different intervals, it comes out the same. We still get the same number of observations. When you get a little bit longer, like with the drums, you have a few extra, but it's only 4. We have 185 observations and there's only 4 extra. So that, I think, is close enough where we can just cut those out and call it good, which is what we're going to do. All those can just go away. Okay, but there's 2 discrepancies that we have to take care of. The first discrepancy that we have to take care of is the fact that we have more information for drumming than we do for speech. They need to be about the same. We can't just cut these off because then we're like halfway through the drumming signal but all the way through the speech signal, and even if there was a correlation, we won't show it because we've got we're cutting off half of the data that we've actually collected. So we need to equalize these in some way. Now, the other thing that we need to equalize is the format frequencies, because for some reason Prot is giving us way more data on format frequencies than it is on anything else. So we have to normalize two different sets of data. How do you do this? Well, it is sort of simple and it's sort of not simple. What you want to do is you want to look at how many extras you have. So just go ahead and start highlighting. So what I'm doing is I'm at the bottom of this column here, our shortest column. I'm moving over to one of the longer columns, and I'm going to figure out how many different observations there are in this group than in the other group. And you can look down here at the bottom. This says there's 40 extra observations. So somehow we need to remove 40 observations from this entire data set. And we need to do it uniformly throughout. So we need to pull out 40 observations in a specific point, in an orderly, non-random way. So what we need to do is we need to figure out how many total observations there are. So we highlight all those, and we see that there's 180 observations. It's really important that you do this with only one column. Let me show you why. If you highlight two columns, it's going to say that there's 360 data points, and you don't want to make that mistake. There's only 180 data points per column. Okay, so we need to move 40 data points out of 180. Remove 40 from 180. How do we figure out how many we need to remove? Do we move every 5? Do we move every 10? What do we do? Well, we can just go equals 180 divided by 40. So what you're doing is you're putting in the string length, which is 180, divided by 40, which is how many we need to remove. And that gives us 4.5. So we need to remove every 4.5 observations. Clearly, we're not going to be able to remove every 4.5 observation. We're either going to have to go with 4 or 5. Usually I would say round. And I guess in this case we're going to round up to 5 because that is what 4.5 rounds to. So we're going to remove every 5th observation. Okay. So how do we remove every 5th observation? I mean, you could go in and you could delete every 5th observation, but that is like a total pain in the ass. Instead, what we want to do is we want to come over here. We want to say okay, so what we want to do is we want to make a column of numbers that is just basically this column of numbers here, but with every 5th number removed. Now, you don't have to do that manually. I'll show you how to do it with a quick, kind of easy formula. So we're going to start at 2 because that's where we are. So we're going to say 2, 3, 4, 5, 6, 7, 8, 9. Okay. What the hell happened? Oh no, I went the wrong way. No. Okay, there we go. So we're going to go 2, 3, 4, 5, 6, 7, 8, 9, 10, or whatever. Okay, so we want to remove every 5th number, right? So we're going to go 1, 2, 3, 4, 5. 6 has got to go. We're going to replace it with 7. Now, we could just put in 7 and then start numbering again, but that's ridiculous. That's going to take all night, right? What we actually want to do is how else can we get to 7 based on what we already have in this number line? Well, we're going to say equals the top number here plus 5. And then we're going to take that, click on that one, double click on this little, see how we have this big giant puffy plus sign, or we have this one where we can move it around. If you come down to this little nodule right here, it turns into a skinnier black plus sign. If you double click it, it'll fill all the way down. There we go. Double click it and it should fill all the way down. Yes, it did. And now look at what our numbers look like. So 2, 3, 4, 5, we've skipped 6, 7, 8, 9, 10, 12, we skipped 11, 13, 14, 15, 17, we skipped 16. Great. So just by doing this one thing, we have skipped every fifth number. Now, you're always going to do it exactly that way. You're going to find the one that you need to remove, and in there you're going to add however many to the first one. Now, it doesn't matter if this starts at cell 1 or cell 10. You're still going to you're going to start the numbering on the cell that they're in, and then you're going to, if you're removing, okay, so look, let's say we're starting at cell 1, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Let's say that we want to remove every third number. So we're going to go 1, 2, 3. 3's got to go. So instead of putting in 4, what we want to do is, how else do we get to 4 using that first number? Well, we just say equals the first number plus 3. So now we've got 4. Click on that 4, double click that little handle, and now we've changed the numbers. So now we're going to go 4, 5, no 6, 7, 8, no 9, 10, 11. Just like that. So it's always going to be the top number plus whatever number you're removing. Every fifth, it's going to be the top number plus 5. Every third, it's going to be the top number plus 3. Every 27th, it's going to be the top number plus 27. Makes sense, right? Okay. Let's get rid of this. So now we've got a string of numbers that removes every fifth. How can we prove to ourselves that this is working? Well, let's go down here and let's see. How many rows long was this piece of information? It's 181 rows long, 181 pieces of information here. And what we want to do is see where 181 is in this new set of numbers that we've made. 181 is about right here. It's much closer to where we needed to be, right here. In fact, what are we off? 1, 2, 3, 4. We're off by 4. So if we were able to pull out every fifth one, we'd only have 4 left over. We could delete 4 and it would be okay. But first we have to figure out how to pull out every fifth, and we're going to use this string of numbers that I have here. Okay, so this is where it's going to get a little weird. You're going to have to use some Excel code. The first thing we want to do is we want to say equals drum, because we want to know what label we're using. Okay, so now we're going to use some Excel code. You're going to hit equals, and then you're going to say indirect, and then you're going to say, so we're doing drum, we're doing the time series for drum. So we're doing column A right here. The time series for the frequency for drum, which is all in column A. So in indirect, we're going to say in parentheses A, and then an ampersand, and then we're just going to select the right here. We're going to type in the cell that this is in. Now I've got this indirect thing over top of it, so you can't see what it is, but if G's here, F has to be this column right here. So it's F2. F2. Put a comma. Double click on true. Close your parentheses and hit enter. And now look. 0.282358 and 0.282358. So we've got the right answer. Excellent. Excellent, excellent, excellent. Okay, well now all we got to do is pull this down until it matches the length of our speech. Pulling it down, pulling it down. And right there, that's where the length of our speech is. Okay, great. Now, if you want to double check it again, the last number that you have here is 2.012358. You can look over here for 2.012358, which should be 2.012358. This is where we've stopped. So we've pulled out every fifth one. We've gotten to this point. We have these extras, which we're leaving off. And I don't like to leave off extras, but the reason why we have extras is because we could either remove every fourth, and then we wouldn't have enough, or we could remove every fifth, and we would have too many. So we have some too many, and we're just going to cut them off. Okay, so this is where we are. This is great. All you have to do is repeat that step for each of these three other columns. Okay, so the first thing is we just want to have the same label. Now we do the crazy stuff. Indirect, parentheses, B, because we're moving to the next column, this column right here. Okay, so B, ampersand, F2, double click on true, close your parentheses, hit enter. Click on this cell, double click this little thing where your cursor gets funky, and you're good. You scroll all the way down, and it should end exactly where the other does. It does, you're good. Great. Now we can do the next ones. All right. Equals this label. Equals indirect. Oops. Using my arrow keys, I shouldn't be. In parentheses, D, ampersand, F2, comma, double click on true, close your parentheses, hit enter. And I don't think the fill handle double click is going to work. It usually goes on how long the column is right next to it. So no, it doesn't work. You're going to have to pull it down. Whoa, too far. Okay, so we'll pull it down right there. Okay, we want to get the column heading. So equals that, and now equals indirect, in parentheses, E, ampersand, F2, comma, double click on true, close the parentheses, hit enter, click on this one, double click on this little nodule, and there you go, you're done. Okay, so let's do it again for the format frequencies. We're going to scroll down. Remember, we want to figure out how many we have to remove. So let's click right here and scroll all the way down. All right. How many observations is that? It is 99. So you've got 99 observations out of how many? Scroll all the way up and only grab one column. Don't get your heading. We have 239. Let's do some quick math. Equals sign 239 divided by 99. So we're dividing the total number of observations that we have by how many we need to remove. Enter 2.41. So this is going to round to 2. We'll just remove every second observation. So we need a new column of numbers, just like we did last time. We're going to start at 2 because that's where we are. Based on these numbers over here, we're at 2. So we're going to go 2, 3, 4, 5. Okay. We're going to remove every second number. This is crazy, right? So 1, 2 needs to go. This is going to be too many. This is going to be too many. We have... We have 239 observations, and it wants to... Let's remove every third. Yeah, let's remove every third. That's going to be too many that it's taking out, I think. We're going to remove every third. So 1, 2, 3. This 4 needs to be a 5. But how can we get to 5 using this first number? Well, equals this first number plus 3, because we're removing every third. Now we've got a 5 again. Great. So we want to take this, move it all the way down. All right, great. So we're going to do a new column here. We're going to say equals. We want the heading first, so get that. And now we're going to start removing things. So we're going to say indirect. And it's going to be a little different now, right? So the first thing is, it's the same. It's in parentheses, but in parentheses we're going to go for O, because we're doing this column now. O, ampersand. But it's not F2 anymore. It's our new batch of numbers, which is in T. So now it's going to be T2 is where those numbers start. T2, comma, double click on true, close your parentheses and hit enter. Now drag that down to where these stop. And let's just kind of spot check this. So we're at 1.71555. And 1.71555 is here. So we're still truncating quite a bit, which I think we're just going to have to live with that. All right. 2 is a lot to cut off. Every second number is a lot. So try to use judgment sort of like that when you do these. But it looks like our formula worked, so we're going to copy the labels over. We're going to copy all the labels first. Okay, there we go. Now, I want to show you something. If you click on this cell that you've already filled in, and you highlight what you've got, and then click Control C, you have to hit Enter after you do Control C. Otherwise, things are going to get weird. Come to the new cell and hit Control V. Now, it's pasted it exactly, so it's just going to be a duplicate of this column, which you don't exactly want. You want the column next to it. So what you need to do is you just need to change O to P. So here in the parentheses, instead of O, we're going to put P. And do that. Now, go ahead and paste, paste, paste. And instead of O, we're going to say Q. And instead of O here, we're going to say R. And here, what do you think we're going to say? Yeah, it's S. Okay. Now, we can grab all 4 of these, double-click that little nodule, and there's all your numbers. Ba-ba. Excellent. So now we have everything that we want. This is what we want it to look like. Eventually what we need to do, and I can show you how to do this, although I think maybe it's getting a little much, the amount of stuff, like we should stop here and do more later. But essentially what you want to do is highlight everything you have. Everything. Control C. Right click at the very upper left corner and then paste as values right here. What that does is it gets rid of all the formulas. It just puts the values in. So instead of, when you click on a cell, instead of seeing a formula, you just see a value. And what that's going to allow us to do is delete all of these original ones. And we'll just be left with the actual data that we want. And then we can do correlation. So I'll just show you. One of the things that I want to do is, let's correlate the intensity of speech with the intensity of drum. So equals CORREL. We'll take that intensity. And it correlates to 0.425. And that's not bad. That's a pretty good correlation. I'd say it's probably a significant correlation, especially considering that we have 130 some observations. 141. 140 observations. So that's pretty good. I'd say that's a pretty decent correlation, and we're going to do correlations with the rest of them too. There's some things that I need to take care of with these undefines. They need to end up being not zeros but just blank, and then we'll see what the correlations are like. Okay, so this is the task that you have ahead of you. It's a little bit technical. I mean, it's really not. It's a bunch of simple steps, but they're on top of each other. So I think it seems daunting, but I think that you can definitely do it. Each step by itself is actually really easy. But when you put them all together, it seems like a lot. So I think just take it, one step at a time. When you get the prot stuff down, put all the data into your Excel file. And I would say do a different Excel file for each different speech thing. So this was ASP1, A speech 1, or a drum speech 1. So we'll just right click on this sheet and we're going to rename it to ASP1. Cool. So then when you want to do the next one, ASP2, hit this new sheet and you can put it in here. So that way they're all separated. And we don't have to try to figure out which one's where. It's all here, but they're all organized into different sheets. We're going to do different workbooks for speech and song, which means an entirely different Excel file. So one will be speech, the other one will be song. That way I can figure out what I'm looking at. Otherwise I get confused. So anyway, that's it. I know it looks like a lot. It's really not. You'll do it. You guys are smart. You're intelligent people. It's not as complicated as I think it looks. So anyway, have fun with it. I think it's a really good way to practice these skills that you might end up using eventually. And then we can all take a look at the correlations together and have a good time doing that. Okay. If you have questions, email me and we'll set up a time once you've had a chance to look at some of the files and try your hand at this. We'll do a Zoom session and we'll discuss any questions that you have, any techniques that you found that made it easier or that I have. So I will look forward to seeing you then. All right. Good luck.